a lot of mathematical foundation established a long time ago. I feel maybe the adoption or the traction of AI really happening recent years because advancement of infrastructure. When I say infrastructure, is hardware, software, so that a lot of things which we think it's impossible to do, now is become very practical exercise.
Welcome to the Conversations on Applied AI podcast, where Justin Grammans and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry and connect with us to learn more about our organization at appliedai.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today we have QingHui Yuan, a director of modeling and data science at Donaldson. Prior to joining Donaldson, he was a manager at Eaton in their hydraulics advanced technology group. QingHui has master's degrees in electrical and computer engineering and a PhD in mechanical engineering, both from the University of Minnesota. Thanks, QingHui, for being a part of the program today.
Thanks for having me.
Awesome, cool. Well, I gave a little bit of an intro with regards to where you're at today, how you kind of went from Eaton to being at Donaldson. Maybe you could put a little more color around it, I guess. How did you get into the field, and how have you kind of progressed in your career?
Thanks for the question. Actually, it's a pretty unique experience for me. My background is control engineering. Actually, I got my PhD in dynamic system control in mechanical engineering. Control is a pretty interesting field, right? It's dealing with all kinds of dynamic system behavior, and then you're trying to bring the behavioral system to the design state. So I think in Eaton days, I was having opportunity to dealing with a lot of complex problems. Mm-hmm. So I take one example, like I'm not sure you're familiar with electrohydraulic valves. It is a control device to control the hydraulic fluid entering and leaving the hydraulic actuator. So all the big construction equipment, agriculture equipment, majority are controlled by this type of fluid. Control device is actually highly nonlinear. You think about the manufacturing millions of different control devices, you're going to have different tolerance. And used to be a very, very tedious manual tuning process to make sure each valve working for each machine. It's unbelievable tedious. So I had an opportunity to develop some kind of electrohydraulic control system. Then the one thing I say, how can we overcome this kind of variation from one system to another? Mm-hmm. Are we able to introduce some of the intelligence to help valves understand like a mechanical data band or different system response, so that they can learn the system behavior and then adjust certain parameter, so that for different machine, different system, they can still maintain optimal or semi-optimal performance. So that part of work actually reflects what is the control domain trying to do, right? You already have a concept of the training your control algorithm to achieve the optimal. You already have like a monitoring kind of mechanism, but it's for the embedded system. It's for the single system. So I think I personally developed an interest when I look at a faster growing domain on the data science. In the end, it's a similar problem, just in a bigger scale, right? Mm-hmm. You have more data, you have a different dynamic system you're trying to predict and hopefully control. So I say, what I learned in the different scale can be applied to a much larger scale, and then have an impact for the different ecosystem. So I started to develop interest from control to eventually data science. And I feel fundamentally a lot of connection and common ground. Yeah, just a little bit of background how I switching from one domain to another.
Yeah, for sure. Well, I mentioned during the intro you have a PhD in mechanical engineering. Do you sort of see that being a unique skill set too? Because like you say, you're talking with these physical systems and all the mechanics going on inside of it, but yet you have all this experience in electrical and computer and engineering?
I feel the multidiscipline certainly help because, in the data science, eventually you solve a lot of different problems. So I think it's very hard to be successful just to stick to input, output, and focus on the algorithm. You have to pull back to look at what is the problem, why that problem important. You have to formulate something, right? And then after you going through the algorithm exercise, apply your artificial intelligence and get some performance, you have to look at what that means, right? What the impact, what that means. So I feel like my training on mechanical engineering, electrical engineering, computer science, and in particular control mindset, I feel gave me a lot of help to understand this kind of multidiscipline element,
Perfect. Yeah, I mean, anytime you're dealing with a physical object in the field and you're trying to get data from it, there's all sorts of things that are out of your control. And so being able to apply, like you said, this multidiscipline approach certainly helps because it's not as straightforward as people would think when you're talking about these control systems, especially the very complex ones that you're working on. One of the people that I like to ask, one of the questions is how do you define AI? AI is such a broad concept, but do you have a short elevator pitch? Either sort of around how you conceive AI, or when people ask you, what do you do in your job? Do you have sort of a way that you like to explain it?
Explosive definition on AI in this case. So I think from my perspective, I keep it very simple. And I call it learn from past, predict the future. So that's basically, if you think about, you call machine learning, AI, the learning, right? Intelligence, like a human intelligence. The reason we be able to hold our bar that high is because we have a continuous learning experience from past, from childhood, from school, from experience. That give us capability to formulate a thought and predict. I think for artificial there, I feel it's the same thing. It's a very simple, you give them opportunity to learn and give them opportunity to predict.
For sure. Yeah. And this concept of AI, I think, has been around for probably since the early days of computing, right? It's everyone's been wanting to make the computers more intelligent. What do you think is different, I guess, today than maybe what we have seen in the past, say the past 10 years versus the past 50 years?
Yeah, I think even from the textbook of the control theory and machine learning, a lot of mathematical foundation established a long time ago, right? Long time ago. I feel maybe the adoption or the traction of AI really happening in recent years because advancement of infrastructure. So when I say infrastructure, is hardware, software. So that a lot of things which we think it's impossible to do, now is become very practical exercise. So that basically opened the door, right, for many opportunity to apply the algorithm developed many years ago to growing application. So I think that enabling piece, I feel, is really key to drive the adoption and actually going to be continue being adopted in the coming year. It just becomes a tool set, right, for many applications.
Sure. Yeah. So what's an example you think of with regards to things that you thought we thought were impossible, 10 years ago or so, and now all of a sudden, I guess I wouldn't say easily solvable, but they're actually solvable today. Do you have an example that you could think of?
One example I feel probably autonomous drive, right? If you think about, you're dealing with so much information and you have to deal with in real time. And even for 20 years ago, you think about that kind of intensity of computation is never achievable in embedded system. And now it's so many car companies are doing that. It's just a common practice now.
Yeah, for sure. Great example. Well, what are some of the problems that you and I guess your organization are trying to solve today that are pretty difficult for you, but maybe in the next, when we talk 5 years from now, you'll have them solved. But I'm just kind of curious, maybe you could shine some light on that.
Yeah, I think for enterprise AI, I call business AI, sometimes we are not necessarily trying to bring the most challenging technology in-house. The many times is trying to understand what are the opportunities. Just to understand what the opportunities, we can apply this kind of new technology to convert from manual process to certain automation and a certain intelligence to make the job impossible possible. I have, I think a few examples. I think in Donaldson, we actually explore several swimming line in the AI or machine learning domain. I can give a few examples because it's pretty broad. It's not like we're just doing this or we're just doing that. It is continuous expansion on our data-driven culture in the organization. And the way for us to do that is always find the most promising opportunity and apply to certain technology, see the success and use success story to educate broad organization and then build the traction gradually. There's a couple of interesting things what I'm thinking the AI help us is the first one I would say IoT space. Donaldson is a filtration company. We're leading in industrial filtration with a fundamental goal to providing clean air to all the application, right? Mm-hmm. So we used to a manufacturing company, just create media, put into element, sell to different application, and one airflow contaminant being captured, then you get clean air. But there is no real understanding on, like for this filter element, what is really happening for the dirty air? Mm-hmm. Is a filter really reach the end of life, or is a filter still in the beginning of usable life? There is only schedule-based maintenance practice in the field. So every 3 months, I'm talking about different application in the truck. Every 6 months, you just change the filter. In industrial manufacturing application, every 2-3 months, you just change a filter. But now we need to actually help customer understand the value story. Did you change it too late, or did you change it too soon? Because there are consequences on each of the side, right? I can tell you for industrial filter, it's actually pretty expensive. Mm-hmm. It's not like $2 or $3. It's a very expensive. You talk about hundreds of dollars. If you just randomly change it based on week or month schedule, you may actually waste a lot of material. Sure. Waste a lot of material. The filter may be only 10% of life. You didn't turn on your factory in 100% of capacity. You still just change the filter as euro, that's a waste, right?
Yes, yeah, for sure.
Another side, if you say, I really want to push everything to the boundary, I really want to push everything to the extreme, then you run the risk of the filter actually reach end of life, lose the capability to filter the contaminant, then contaminant getting into your equipment. I think we have a very wide application from aerospace, transportation, off-highway, industry manufacturing. But in the end, your equipment is going to be vulnerable for the performance and the life. Some dirt maybe kill your engine. So we basically think, introduce sensing as a starting point into our filter. And then when you receive like a pressure signal, temperature signal, you can start to learn. You can start to learn what's going on. You can start to learn what is filters real life based on the sensing data. That's one thing. And you can also learn what is operating procedure and the duty cycle for different applications. So that training and learning going to give a tremendous insight for us to understand what is the right maintenance schedule, what is recommended inside to the customer in a different field, and then eventually fundamentally create a value for them, right? Create a value for them. So this is one example. I think it's very practical, and you deploy the sensing element to the field, and you collect the data. You use AI to starting to understand the pattern, understand the trend, create the insight, and then help a customer make a change on their action. So this is a control system. If you think about it, it's a control system. They change their behavior, they change their supply chain system. So you don't need to put a pile of the element in your field as an inventory. So because all the information flowing, you can streamline the supply chain. And once you reach end of life 3 weeks ahead of time, you can inform ordering system to kick off, then you get the parts right on your door, right? So that kind of things are pretty amazing and create a tremendous opportunity.
You're right. Very, very practical example, because it's not a one size fits all. Every organization is going to be using their filters differently. And you're right. If it's just a standard time, come out and change it. Too early, too late. And there's consequences on both sides of that. And then I think what's really cool too is that you're talking about it percolating through the entire system, right? So you're right. There's the entire supply chain side of it, where now you don't need to store all these things, or it's just in time ordering. So it makes a ton of sense for an organization to sort of employ, or I guess I would say deploy some of these technologies within their company. What's some of the challenges? Like, I mean, obviously that's okay. So we have this solution we're looking at. There's everything from the sensors to the connectivity that need to be set up, to the data ingestion, to, I mean, just to filtering out all the noise that maybe is going on within that. What are some of those challenges then, if we stay on that sort of like really awesome business use case? What are some of the challenges that you're seeing as you actually go to build out this technology in general, I guess, you know?
Our practice to solve the challenge problem. The day of life could be a lot of technology review meeting. It's a conversation with a supplier or technology provider partner, and also have some kind of logistic piece. You have to consider investment budget. You know, hey, we want to have this big investment next year for this technology. How we figure out investment framework? Because it's too late. You want to do tomorrow, and you talk about the money, right? So
right.
There's some of those part, and hiring and recruiting in data science domain. I feel it's very challenging. Actually, I'm growing the team on the data science side. I witness of some of the challenge, how you find right talent in this domain. And you have to be able to spend more time to understand market dynamic and be flexible and able to get the right people into the job. And personally, I think I want to reserve some time to absorb development in this area. You know, this is a fast growing area on both data engineering, data science, you know, almost every domain, you know, 10,000 companies pop up right in this domain every year. Sometimes you probably feel two hands full, but you know, have to maintain that kind of learning agility every day to see what's going on and make sure stay on top of the field. But you just feel like it's just so exciting every day, and the time is a biggest enemy. So.
Yeah, for sure. No, I know what you mean about trying to stay engaged and learning new stuff. That was kind of the reason behind sort of this podcast and the Applied AI group, is just getting more and more people together to talk and learn from each other. I'd like to dig a little bit on the hiring and recruiting stuff. Like, what would you suggest people do? Are there any books or classes or conferences or stuff like that? Any places that you have found, other podcasts or places that you found sources of inspiration that maybe you might suggest to people?
Well, there's a lot of perspective. Maybe I will talk line by line, just my perspective. From cost perspective, right now there's just so many resources available. I feel like you can just grab any of the reputed university institute. There are a lot of high quality courses available. I think my suggestion is maybe on one, focus on some fundamental, really understand what are the operating principle underneath some key algorithm, because there are a lot of open source package available, a lot of solution available, and it's probably getting less important for implementation to let you write the 1,000 line code for one particular algorithm. It is a utilization and choose the right one to solve the right problem. So build the fundamental understanding of the different piece, how they play together, working well on different conditions, is more important than the implementation of individual algorithm. The number two, on the cost side, I feel like right now the things are moving from PC and on-premise setting to cloud. So I feel for data science practitioner, maybe find one or two. I don't care it's AWS or Microsoft. You choose one. Just get a little bit flavor and a certificate on how the data science platform working together with the ecosystem, right? Mm-hmm. Database, cloud warehouse, streamline mechanism, bus, visualization. Just get a little bit of flavor of, okay, I eventually going to deploy that not on my PC.
Right.
It's going to deploy it on this internet. So what are the other basic elements I need to be aware and to connect with the algorithm and the AI piece? I feel like that's going to provide a little bit of boost to the career.
For sure. Yeah, no, it's a big difference between, like you said, I was kind of laughing with regards to like, running something in a Jupyter notebook on your computer to bringing it into a full sort of ML ops pipeline where, models can be adjusted on the fly and all that sort of stuff out in the field. So great perspective. Well, we're getting close to the end here. I'll put some liner notes, so I'll put a link off to whatever sites you want to have people check out, both across the board here. But yeah, how do people reach out to you, QingHui?
Yeah, LinkedIn is a perfect choice. And I actually spend a lot of time on LinkedIn for the continual learning. So I'm pretty proactive over there. So, connect me, feel free to connect me over there, send a message, and willing to share whatever I have.
Awesome. Cool. Was there anything else you wanted to talk about? Any subjects you wanted to touch on around artificial intelligence?
Just an interesting fact, right? I just recently learned how much impact of machine learning and AI to our daily life, which I didn't pay attention previously, because we think, data itself is a bigger problem. Connect the data, connect the algorithm, deploy. I think that occupied majority of my thought. Recently, I heard the energy consumption of training for AI. I think one of the study from IBM showing one sophisticated algorithm, AI algorithm, just for training, the electricity for the training is equivalent to carbon footprint of 5 cars in its lifetime. So just think about this fact, it's a fascinating eventually if you think about, okay, it's not only about the digital impact, because the digital is going to have a consequence on electricity and on the physical world. So if we deploy more and more, and this kind of energy consumption and other things will be eventually linked to our daily life. So I know the data center already consume like 10% electricity. So I just consider moving forward, the more model being deployed, and that part is going to be a bigger factor in future. So I just feel like it's interesting to share that observation, and we'll see how that go. People will starting to pay attention to energy efficient training, energy efficient computation, or maybe move some training from cloud to edge. All kinds of things are going to develop, and it's just a very interesting angle. I just learned. I feel like maybe worth share with the audience.
Yeah, that's great. That is great. Yeah, I mean, training models aren't free, like you said, from an electrical standpoint. So just you think you're going to pay for it down the road because you could potentially deploy this model out somewhere in an air conditioning unit that would be smarter and would only turn on when it needed to and all that type of stuff. But the impact to actually train that model costed you something. So it's sort of it needs to be a net positive at the end of the day. And you're right. I guess I hadn't really even thought a lot about that. Most people are so busy just training models for the sake of training models, and they don't really know that there is actually a cost to that. That's great perspective. Excellent, QingHui. I appreciate you taking the time to talk with us today and sharing your knowledge, and look forward to hearing more from Donaldson and yourself, obviously, as you move throughout your career. And all of us are kind of learning and sort of building on each other in this new and exciting space. But I want to say thanks again for being on the show, and hopefully we'll have you back in the future again to talk about what's changed.
Justin, thanks for the invitation. It's a great pleasure to be with you today. Yeah, anytime in future.
Great. Take care. Bye.
Thank you.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at appliedai.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at appliedai.mn if you are interested in participating in a future episode. Thank you for listening.